Hello friends, welcome to Welding Inspection and NDT. Today's topic is all about APA 510 minimum required thickness and remaining life calculation. In our case, we have a pressure vessel and its details are given right here. And its design pressure is 600 psi and inner diameter of the vessel is 50 inch that means radius is equal to half of 50, this is 25 inch. Nominal thickness of the vessel Tn is equal to 1.20 inches and allowable stress equal to 20,000 psi. Joint efficiency E equal to 0.85. That means we have only done spot radiographic examination, and corrosion allowance is 0.125 inches. Metal loss is 0.1875 inches. A 10 year of service and no corrosion in the well is observed. And the question is whether the vessel is safe for operation or not. And also we have to find out minimum required thickness and remaining life. First we will calculate the minimum thickness calculation. Minimum thickness is the thickness that is required to resist the hoop stress. T minimum. The equation to determine the minimum thickness is P into R times divided by SE minus 0.6 P, where P is the design pressure, R is the radius of the vessel, S is the allowable stress which is given in ASME section 2 part D, E is the joint efficiency, and P is already mentioned, that is the design pressure. In our case, our design pressure is 600 psi and radius of the vessel is 25 inches and our allowable stress is 20,000 and joint efficiency is 1. So we will put these variables into this equation, then we will get a minimum thickness which is equal to 0.7637. That means this is the minimum thickness, that is 0.7637 is the minimum thickness that is required to resist the hoop stress. In our case, we have taken a joint efficiency of 1 right here rather than 0.85 that is given in our question. Why? Because as per APA 510 clause 7.4.5, if the corrosion patch or area that is subjected to the corrosion away from the well more than 1 inch or 2 times of the required thickness, whichever is greater, then we can consider the joint efficiency as 1. In our case, the corrosion is happen not on the well, it is away from the well, that is, it is 4 inches away from the well. That's why we have taken a joint efficiency of 1 rather than 0.85. So our minimum thickness in order to resist the hoop stress is 0.7637 inches. The next we have to calculate the remaining thickness. In order to determine the remaining thickness is the difference between the nominal thickness and the actual metal loss. Our nominal thickness is, which is given in our question, that is nominal thickness 1.20 inches minus what is our metal loss 0.1875 inches. So the remaining thickness 1.20 minus 0.1875, that is the nominal thickness minus metal loss, we will get 1.0125 inches. Since our remaining thickness is greater than the minimum thickness required to resist the hoop stress, that is T minimum, our vessel is safe to operate. What is our T minimum? Our T minimum is 0.7637 and our remaining thickness is 1.0125. Since our 1.0125 is greater than 0.7637, the vessel is safe to operate. Next, we have to calculate the remaining life. In order to calculate remaining life, we needed the actual thickness, the required thickness divided by the corrosion rate. First of all, we have to calculate the corrosion rate. The corrosion rate is the difference between nominal thickness minus the current thickness divided by year between the operation. Our nominal thickness is 1.20. In our case, the nominal thickness is 1.20 and the current thickness, which is equal to 1.0125, and the year between the operation is 10 year of service. That means our corrosion rate is 1.20 minus 1.0125 divided by 10. We will get 0.01875 inches per year, or 0.45 millimeter per year. That means our remaining life is our corrosion rate is 0.5 millimeter per year. So our remaining life is T actual minus T required divided by corrosion rate. What is our actual? T actual 1.0125. What is the required thickness in order to resist the hoop stress, which is equal to 0.7637 divided by 0.01875. We will get an remaining life of 13.26 years. That means our vessel have a life of 13.26 years. Hope this lesson is clear to you all, guys. Please subscribe my channel for more videos. Thank you for watching. Thanks once again.